Welcome to APCUG's Wednesday workshops, where we get together on the middle of the week and spend a couple of hours together learning about technology from lots of different fields. Today, we're going to be talking about pies. Now, not fruit pies, not pot pies, not even moon pies or whoopie pies. And we're not even going to talk about that mathematical pi. Today, we're going to be talking about a Raspberry Pi. And I hope that there's a lot of you here who have no idea what a Raspberry Pi is, because that'll make this workshop very beneficial. And later on, if there are some of you who have some experience with Raspberry Pi, we'll give you a chance to share back with us. You won't hear much from me because I have a Raspberry Pi that's sitting in a box over here that hasn't been out of the box in a year and a half. And I need to get it out and do some more with it. So maybe today I'll get some ideas and some help to get it going and started. Our team of presenters today is Orv Beach, Dave Melton, and Cal Esenault. You've seen most of them before on either workshops or VTCs. So again, if you have questions, please put them in the chat box addressed to Judy. Because if you send it to them, they may not even see it. If you have issues with Zoom, send those to Bill. And otherwise, I'm going to turn things over to Orv Beach.
Thank you, John. Good morning, everybody, or afternoon, depending on where you are. Thanks for the nice introduction, John. Let's see here. Oh, yeah. It's early in the morning here. Still getting my act together. Let's see. How's that, John? You see that?
Yes.
Okay. All about Raspberry Pis. Raspberry Pi was one of the first what they call single board computers. You may remember in the early days of PCs, you had lots of slots and add-on cards to add functionality. Original PCs didn't even come with serial ports, and there was no such thing as Ethernet. When it did come along, it was a plug-in card. Well, as parts have gotten smaller and smaller, and more functionality crammed into integrated circuits, it became feasible to put all the stuff for a functioning computer on a single board. The Raspberry Pi was one of the first ones, and they've proliferated since. If you ever search for a list of single board computers, there's at least several dozen there. A lot of them are ARM based, like the Raspberry Pi. A number of them are x86 based, so they will run native versions of Windows or Linux. We'll talk about that a bit later. Initially, the creators of the Raspberry Pi created it for training, for teaching people programming. And they signed a contract with a small manufacturing company, and they figured they might sell, I don't know, 10,000 of them over the life of the product. Well, they opened sales in February of 2012, crashed the ordering server because of demand. They sold out within a few minutes and took over 100,000 pre-orders. And reports were, at that time, there were over 2 million people interested in buying one. And as of May of this year, over 40 million have been sold. Just a note, I'm going to show you all sorts of bits and pieces, but if you don't have Raspberry Pi, a number of companies make starter kits. CanaKit is one of the big ones, C-A-N-A-K-I-T. If you just search for CanaKit on Amazon, you'll find lots of different kits. So let's dive into what's in there. We'll look at the different flavors of hardware that are currently being shipped. There's lots of older versions being run out there. This is Raspberry Pi Zero. It's a stripped down miniature board, and you can see that it's quite small. USB power, no Ethernet. It's got wireless. The two rows of holes you see there are for a GPIO connector. GPIO stands for General Purpose I/O. In addition to power and ground being available there, there's serial ports, some programmable input and output ports, and we'll look at that more. That spot on the board is not provided with a connector on the Raspberry Pi because they figure it's going to be embedded and you'll just solder wires on it anyway. The Raspberry Pi 3, the B Plus is the latest version of this model. Up until the Raspberry Pi 4 came out, this was the highest selling and newest model. Dual band wireless, Bluetooth, BLE, which is Bluetooth low energy. It's a very low version of Bluetooth, very low energy, low power. You can put a terminal on this and successfully run an OS with a GUI, but generally this is the one you make into a general purpose server, like a file server, a little web server, and for various other functions like telemetry and monitoring. This is the latest one. This is the Raspberry Pi 4 Model B. It's been upgraded, like as time goes on, everything electronic does. You can see the GPIO has a connector on it with is it 32 or 48? Anyway, the GPIO has become the standard connector for small board computers for I/O. This particular one has dual, I think I call it micro HDMI or mini HDMI. See those down at the bottom. Still has an analog audio output jack, Ethernet port, USB, and this particular version you can buy with 2 gigs, 4 gigs, and 8 gigs of RAM. If you're going to run it as a dedicated desktop, I recommend a minimum of 4 and probably 8 gigs of RAM. That's because, believe it or not, running a computer as a desktop, yanking all those high-res images around on the screen is the hardest thing a computer can do. Serving out web pages, serving out Ethernet, database work, that's all I/O. It's not challenging for a computer. Running a desktop is.
Or could you close out that little message in the bottom left corner of your screen?
Will do. Thank you. This is the newest model, the Raspberry Pi 400. If you knew you were only going to run it as a desktop computer, you could consider this. You can see all the I/O connections on the back. There's a Ethernet on the right and power, then a USB 2 port, and the 2 blue ones are USB 3. Looks like, and I'm sure what that one is there, and a couple of the HDMI ports, and oh, the little slot next to the connector is for the micro SD card. And that looks like the GPIO connector there. Because it's an open design, vendors jumped in, developed all sorts of add-ons for it, useful stuff. And one of those are cases. And I'm just going to do a quick overview of all of, this is just a fraction of the cases you could buy. On the upper left is one, a very generic plastic one. This is probably this is very similar to what you'd get with CanaKit. And just as FYI, a lot of the Raspberry Pi 4 cases come optional with a fan because it does run hotter than the previous versions. And if you're going to run it as a desktop computer, or you're going to be pushing the CPU, I recommend you get the fan. On the lower left is a metal case. The case is used as a heat sink, and they've moved all the connectors around to the back with cables. makes it look like a real computer. On the lower right is a plastic case, but you can get the plans and download these and 3D print it yourself, which I thought was pretty cool. If you're going to mount something on the back of a terminal, there are on most monitors 4 screws in a square rectangular pattern. No, it's square pattern called VESA. I forget what it's called, but it's a standardized screw hole pattern, either 75 by 75 millimeters or 100 by 100 millimeters. And they make a case where you can mount your Raspberry Pi on the back, so you can get it off the desktop and out of the way. Here's a couple of others. The one on the left has a touchscreen panel. So if you were going to run, oh, I don't know, home automation server, and we'll look at those in a minute, or maybe a recipe computer on the kitchen table or something like that, you could use that. The one on the right, I think is plastic, but you'll notice on the back of it, it's got a bracket for mounting it on a wall, so you get it up out of the way. And if you're into brightly colored neon fans inside your computer, the case on the left is for you. And looking at it real closely, that pipe in there looks suspiciously like, well, it might be a copper heat pipe, or it might even be liquid cooled if they're overclocking it. The one on the upper right, I found it, some designer came up with it. All the connectors are moved around to the back. And the lower right is just another one designed to be a desktop computer. And I duplicated presentation slide, sorry. So as far as the hardware you can add to it, hats are hardware attached on top. The GPIO connector was meant to be stacked. So you can stack multiple hats on top of it for multiple purposes. And I've got a few slides showing just some of the wide variation of hats you can buy. Data acquisition is where you capture a large number of inputs, be they digital or analog, and you can see this one has 4 DAC cards stacked on top. And through the stacked GPIOs, the Raspberry Pi can access all of the inputs on all of those boards. On the right is they called it a sensor input. There's a push button, a rheostat. Those white things are, I believe, keys for a multi-key keyboard, and all other sorts of stuff for experimentation. On the left is the automation hat, over and above providing power. Down at the bottom, you can see relay connections, normally open, closed, so you can cycle power on and off to various things as needed. On the left side, there's a 12-bit ADC, analog to digital converter. You can take a voltage in, convert it to a digital or binary number, and the Pi can pull it in and deal with it, display with it. I don't know, if it's too high, like it's a temperature, you could turn on a fan. When it drops down, you could turn off the fan, something like that. There's also some open collector outputs. Basically, you can put a wire in there with a DC voltage on it and ground it through one of those. And the buffered inputs are digital inputs. They can tell whether there's a high or low on a wire with a binary number on it. So you could pretty much roll your own monitoring with that. On the right is an environmental hat. It's got a light sensor in it, a motion sensor, barometric pressure and temperature, and an analog in over and above 5 volts and ground, 4 analog inputs for measuring various voltages that would come from sensors. This could be used in again, a home environment thing. So on the left, you can see stacked on top of a Raspberry Pi there, a touchscreen, 18-bit color, not too shabby. 800 by 480 is plenty big for a teeny little screen like that. And on the right, I'd seen camera cards for Raspberry Pis before, but I'd never seen a stereo setup. I think that's pretty cool. On the left is a PoE hat, power over Ethernet. Raspberry Pi takes USB power, that's 5 volts. If you were going to put a Raspberry Pi someplace remote away from an AC power outlet where you could plug in the wall wart, and you were going to connect an Ethernet cable to it, you could run power over Ethernet over the 2 unused pairs in the Ethernet cable, run it into this board, and it would take and convert it down to 5 volts to power the Raspberry Pi. On the right, if you're into SDRs, software-defined receivers, you've seen them mostly as a USB card. Single channel, they can do, I don't know, 100 kilohertz up to, some of them will go 1.5 gig. This one is a dual channel. You can receive 2 frequencies simultaneously, and these go up to 6 gigahertz. And you can see the 2 gold connectors on the left. Those are called SMA connectors. Those are good for SHF frequencies. But if you really want a really low loss connection, you can see those 2 circular gold connectors on the center of the board. Those are clip-on wireless. Those are for clip-ons for wireless antennas, the whips and the beams. They use this even smaller connector. So let's talk about operating systems. In the beginning, there was Raspbian, which has since been renamed the Raspberry Pi OS. You can get it with a desktop. You can get it with a desktop and their recommended software. And not to worry, if what it comes with isn't what you need, you can install it by downloading it from the repository and adding it to your computer. Or if you're going to run the thing as a dedicated application and do what they call headless, no keyboard, no screen, no mouse, this is what you'd put it in. This is the OS you would install. Comes with no applications, and you install what you need. Not too long ago, Debian 10 was ported to the Raspberry Pi. It's not as big a deal as you think because many Linuxes, including Raspbian, are ports from Debian, so they're very, very similar. You'd feel pretty much at home with either one. Debian 11 was released recently, so I wouldn't be surprised if it's available for the Raspberry Pi now or in the very near future. Fedora Linux is another Linux. It tends to be a little more bleeding edge than some of the other Linuxes. But when it comes to Linux, when I say bleeding edge, I mean tiny little scratch. They're all very, very stable. LibreElec, I just copied here because I found it. It's an entertainment center distribution. Presumably it's loaded with games. The Ubuntu desktop is available. The Ubuntu server is available. So if you run Ubuntu server as a home server on a big desktop and it's not heavily loaded, here's your chance to move all your data onto a tiny little server and save some electricity and some space. And I also found RetroPie. Presumably this has all these video arcade games from, I don't know, 70s and 80s, maybe 90s. And there were at least 30 others. So you can feel free to start with any one you want. If you're comfortable with Ubuntu, go with that. Although honestly, there isn't a lot of difference between Ubuntu, Debian, and Raspberry Pi OS. So I looked at home automation, and it turns out that's a very, very popular application for a dedicated Raspberry Pi. You can run it on a web page or one of those touch screens. And this is Mr. House. It's nice to see the all of the buttons for the features here, but you have to understand for every one of those, you have to run cameras or run cables to cameras and sensors and stuff like that, or do it wireless. So depending on how big you go, it could be quite a substantial project, but one you could take on bit by bit. Here's another one, open habitat, OpenHab. Again, turn stuff on and off. Apparently it controls the TV. Let's see, temperature, open and close the office window. All sorts of good stuff. And here's something called Kala OS. I guess that's it, Kala OS. Again, close the shutters, turn the lights off, turn the corner light on, dim the lights. And down at the bottom, I don't know if Philips has those smart lights you can change the color on. Apparently down at the bottom, there's a control for those, the hue of those lights. This is called Gedem. I think it was originated in France, which is why you can see the French labels, but it looks, apparently it's partly cloudy there. And 8 degrees C, that's quite chilly. So we're going to look at a couple whole real life applications. I don't know how real mine is, and Dave will follow with his, which I think is more interesting. But anyway, this is something I put together. It's not at home, which is why it doesn't look pretty at all. This is in a building on a hill on the west end of town, and this is used to monitor the environment in a building that houses some ham radio equipment. It's a weatherproof box that was given to me, came out of a manufacturing plant, actually. Down at the bottom is the terminal strip where all the power and ground and signals come in. Just above the terminal strip is a converter that takes 12 volts in on the right, red and black wires, 5 volts USB out on the left, and goes up and powers the Raspberry Pi, which is at the bottom of that stack of boards. Just above the 5 volt converter is a 12 volt to 24 volt converter. That's used to power some of the ham radio equipment that needs that voltage. And you can see going off to the left, you can't see it, but there's a digital voltmeter on the front panel. It tells me the status of that 24 volts. The stack of boards at the top, the Raspberry Pi is at the bottom. You can see the Ethernet cable going into it. On top of that is an ADC board, analog to digital converter board. I measure battery voltages around, we use batteries for backup power, and we're able to monitor those there. Because the Raspberry Pi is a 5 volt board, no ADC can measure greater than 5 volts natively without help. Stacked on top of the ADC board, you can see that prototype board with all the solder pads on it. I put some resistive dividers there to scale the voltage down to, I don't know, about 1/3 of whatever the battery's peak voltage is, I think 13.8. And yes.
Could you point to everything as you're talking about it?
I can.
Thank you.
Starting from the bottom, here's the terminal strip. I salvaged that from someplace. Here's the 12 volt to 5 volt converter going up to the Raspberry Pi. This is 12 volts in, 24 volts back out to gear that's down below, out of sight. Over here is a digital voltmeter on the door of the box, of the enclosure. We run 5 volts up here, Ethernet up here to the Raspberry Pi that's on the bottom of the stack. You can't see the ADC board, the analog to digital converter board, but you can see the nylon posts I used to stack them. On top, you can see these terminal blocks here are actually part of the analog to digital. This is where their voltages would come in, but they can't handle more than about 5 volts. So I run all of the voltages I'm monitoring here, drop them through a resistive divider here. There's 2 of them. We monitor 2 voltages. Send them back out and back down to the ADC board where they can be measured and reported on by the Raspberry Pi. So here it is in its glory, and you can see the voltage over on the left. When I'm in the building, which is rare, I turn the monitor on and use the keyboard and mouse. Most of the time, monitor remotely. I do measure temperatures with this. There's two ways to do it. The easy way is with USB pluggable thermometers, and some of them measure humidity. The hard part of that is the main vendor of those, the most popular vendor of those USB thermometers keeps changing the interior hardware of the device and not changing the model. And all of a sudden the software stops working. So we've had to do, I think, 3 iterations of it. There is an easier way to measure temperatures. It requires a little of hardware wiring, but not much. The Raspberry Pi has a serial bus on the GPIO called I2C. I think it actually means IIC, but it's a single wire, low speed serial port. And what you do is you send power and data out to a little widget like this up here in the red circle. And unlike a regular serial port, you know, with ASCII code, this sends a number out here. Every sensor has a unique address. And if it sees that number corresponding with its address, it sends a number back that corresponds to the temperature. And that comes into the Raspberry Pi, and you can interpret it and display it. The nice thing about the I2C bus is you can hook up to, how many is 254 or 255 on the same serial bus. So you can run one wire all over the place, as opposed to your, I don't know, what is it, 10 or 15 foot limitation on USB. You can't see it, but another one runs down here and out and up and drops down weatherproof behind the building. So I get the exterior temperature. And I display it on a web page. I took this at night, so, you know, among other things, this web page is displayed by the Raspberry Pi, and it takes a screenshot every 5 minutes of the 3 video cameras there. External security, internal security, and the fuzzy one off to the upper right is the pan tilt zoom camera. It doesn't focus well at night, but it works well for tracking brush fires during the day. The telemetry is down at the bottom. Inside temperature, outside temperature. I monitor the power output of a 5-volt wall wart. If it goes away, I know that the power to the building has failed, and it flags it here. You can see that the SMRA repeater battery backup voltage is 13, and you can see the DSW repeater backup voltage is 7 volts. Obviously something is wrong there, which is true. The batteries failed and the new ones have been delivered and we have to install them. That's a lot to take in. You can start out simple with a Raspberry Pi and learn a little Raspbian or Raspi OS, or if you load Ubuntu on it, you're up and running. But if you, like I said, if you're going to run it as a desktop, fill it up with RAM and go from there. They make enclosures with a slot in the top, so you can put a ribbon cable in there connected to the GPIO, but generally you won't need all of those ports. So you can start small. How's that?
Always good to start small. Don't start big. Judy, anything for Orv? She's checking.
Checking it twice. Oh, Gabe has a question. Very important. Why in the world is it called Raspberry Pi?
That's a great question. Let me Google that for you.
I was going to say, that's what, honest to God, I was going to do that and send it back to him, but I thought more than one person might be interested.
Somebody may know.
I'll Google it while, you know, the next presentation's going on. Okay. Has anybody ever used a Raspberry Pi to control an X10 lighting system?
Yes, I've seen them out there. They're designed for it. I'm sure there's dedicated applications. In fact, I wouldn't be surprised if most of those home automation applications have an X10 control module in them.
Okay. We have a link that'll be in the handouts to a Raspberry Pi project that was programmed in Ada 2020. And George said, please don't be discouraged if you don't solder. The GPIO header is pre-soldered on most Pis, but not on the Pi Zero.
That's correct.
Jolynn asks, what are the pros and cons in using a Pi with the Windows 10 ARM software as the OS?
It'll never be as fast as your desktop.
Okay, that's a con. Are there any pros? Obviously not.
Takes up less disk space.
Okay, that's good enough.
Uses less power.
2, all right. Does the keyboard version of Pi have an internal fan?
I don't, oh, it's based on the Raspberry Pi 4. I don't know, but I suspect it does.
Okay. And Gabe patted himself on the back and said, I specialize in asking good questions.
Props to Gabe.
Does this boot into the program without a need to log in?
It can be configured that way.
Okay. If I want to measure the temperature in 3 places, outside, inside, upstairs, downstairs, for example, well, that was 4. Do I need those places for connections on the RPI?
I'm thinking, you know, in general, it's always better to go wired when you can and wireless when you can't. I have run Ethernet around my house in several places, and it's tedious, difficult, and sometimes dirty, sometimes impossible. These don't need Ethernet. All they need, if we're talking about the I2C serial port cables, and which you'd have to do for those distances. You couldn't do it via USB. If you're handy with a drill and you don't mind drilling small holes in walls, you know, you can do that. Seriously, I did that in a closet with an Ethernet cable and it worked fine. I'm just trying to think if there was a wireless solution, and nothing comes to mind, but I would recommend, you know, Googling measuring temperature with a Raspberry Pi remotely or something like that.
Can you connect an Sshd to a Pi?
Yes, and recently that's become possible, and it is the desired solution because it's substantially faster than the little micro SD cards. You get much better I/O performance.
Does using the various cases require a lot of soldering to connect to a Pi?
No, none, 0. Well, none of the ones I've encountered. Let's put it that way.
And that is my last question.
One little comment. You can buy all different sizes and qualities of SD cards, and they'll all plug into it and they'll all run. But a lot of the cheap ones don't have a large number of write cycles. If you have an application that's writing data constantly to an SD card, you'll wear out one of the cheap ones in a couple of years. So, by the way, there are lists of recommended micro SD cards for Raspberry Pis. If you buy a kit, it'll come with one. If you're assembling from parts, make sure you buy a good quality one and buy it off the list, the recommended list.
And where is that list? When you buy your Pi, it's folded up on a little piece of paper or something?
Well, if you buy the kit, it comes with it.
Oh, okay. How do you know it's a good one?
You Google good SD cards for Raspberry Pis. There are lists out there.
Or you DuckDuckGo it. Let's give John.
I've switched. Yes, you're right.
Okay.
That doesn't sound nearly as good as Google, though.
I know.
Maybe we'll have to do a Dougal or something.
We have a presentation, by the way. Is it practical to write and to compile software for a Raspberry Pi on a Raspberry Pi?
Yes, just like every other computer. The huge universe of languages and programming tools that's available for Linux is available on the Raspberry Pi because it's just a Linux computer. That being said, if you're compiling a massive ARM-based program, you might want to cross-compile it on a faster computer and then copy it over there for testing.
I know absolutely nothing about this. Where do I start? And how do I find out from top to bottom what I need to do?
Buy a starter kit from Canakit, C-A-N-A-K-I-T, Amazon. I think if you get the Raspberry Pi 4, it's around $100, but it comes with a case, power supply, fan, SD card, and instructions on getting started.
Okay, that is it. And I have to say that I had my 50-foot Ethernet from the back bedroom down the hall, through the dining room and into the family room. And I called it because it was the same color as my porcelain tile, but I held them all down with high visibility green duct tape. And then Spectrum rewrapped my house for me.
I have a quiz question for the teacher. What's the maximum length of an Ethernet cable?
John?
No, I'm asking you, the teacher.
Oh, I haven't got a clue. Don't tell me it's less than 50 feet.
No.
How long?
100 meters.
How long is 100 meters?
Oh, come on, 330 feet. That's metric. Teachers should know metric.
Not teachers of little kids.
Well, okay.
John Kennedy didn't know it either. Okay, so I don't feel so bad.
Seriously?
I was going to say 333 feet.
That's close enough.
I was going to say a football field.
Yep.
And then some.
Oh, I thought it looked nice myself. Anyway,
I've done the same thing.
Over to John.
All right, so that's a good start. There's going to be a lot of questions, I'm sure, at the end, and a lot of answers and stuff. So those of you who are totally new, we can take you back to what I do and just plug it in and play with it as a computer. But we're going to switch now to Dave Melton, and Dave's going to share with us about what he's doing and some more information. So Dave, I'll turn it over to you.
Thank you, John. So in sort of tagging on to what Orb shared, I've got a project that I put together that I'm going to share with you. So I'm going to share my screen here. And why isn't it sharing? There we go. I think that's the one I want. Doesn't it tell me? Well, let's find out. Nope, wrong one. Stop share. Let's try that again. How about this one? Okay, can you guys see that okay?
I can see your sprinkler.
Perfect, perfect. That's what I wanted. So my project was a sprinkler timer. So I kind of got the idea by playing around with a Pi. I played around with Pis since about 2013, which is about a year or so after the original Pi came out. And recently I wanted to change away from my Weathermatic sprinkler timer. As you can see here in the corner, the city gave me this. All I had to do was attend a class. But I got tired of fiddling with it and I wanted something to do. So I put together a, well, how come I'm not moving forward here? Nope. Okay, so let's try that. How's that? So what this is not popping up with my notes here, but anyway, I'll wing it. The reasons I put together this timer is, you know, we all have lawns. Most of us probably have timers that we use of some sort. And one of the questions that came up, is it more configurable than the regular timer? Is it easier to use? Is it any better? How about cheaper? Cheaper for sure. Well, except for mine that was free, but typically they're over $100 at a big box store. But the real reason I put this together is because it was fun to build and it gave me something to do. Next. So I had to figure out what I was going to do and how to go about it. So I figured I needed a Raspberry Pi, and of course the micro SD card that we've had a lot of discussion about. I needed a transformer to power my valves and my Raspberry Pi. So it's from 110 volt to 24 volts. And then I needed a regulator for the Pi itself. And the 24 volt relay board, which the sprinkler valves that we use here in Southern California are 24 volts AC. And I also needed a cable to connect the GPIO pins to the relay board. And of course, I wanted a disconnect switch to disable the relays in case of a problem. And I don't know if you guys have ever experienced a problem with a stuck relay, a stuck sprinkler valve, but I wanted to be able to turn it off and disconnect it from my Pi. And I don't build any project without a power fuse. So I needed one of those and a project box, and then some LEDs for experimenting. So I chose a Raspberry Pi 0WH. And this goes into what Orb was talking about. The W is Wi-Fi. If you notice on here, there is no Ethernet connector. This is HDMI here. So you can hook a monitor to it. And through one of these micro USB ports, you can hook up a keyboard. And then this one that I bought with the H model has a header already soldered onto it. And I didn't want to do the soldering, so I bought it with a connector on it. So here's my transformer, just similar to what you would have for your doorbell, if you still have an old-fashioned doorbell. And here's my little regulator, the voltage regulator. It transfers the voltage from 24 volts AC to 5 volts DC to power the Raspberry Pi. Now, 5 volts DC is what you would have to charge your phone. The Raspberry Pi has a USB connector on it, so it's pretty simple to hook it up. Here's my 24 volt relay, which all these connectors here will go to the sprinkler valves. And these pins down here are what connected to the Raspberry Pi. So the Raspberry Pi GPIO pins turn on, for instance, relay 1 here and connect it to the sprinkler valve. And here's what I used, some of these wires to go from the GPIO pins to the relay board. And then I bought some LEDs, some switches, fuses, some connectors to put everything together. So here's a summary of what I did. I actually bought the Pi 0WH and a micro SD card, and I ended up buying 2 micro SD cards, and I'll show you why in a bit. Now, to make it all run, you need the operating system, Raspberry Pi OS, which is based on Debian, as Orb mentioned, just like Ubuntu is based on Debian. So that's just to make the Pi work. Now I needed to make the GPIO pins work. So I had a bunch of options. I could learn Python scripting or Bash scripting and turn the pins on and off myself. or I could purchase some software. I didn't look a lot about that because I didn't really want to purchase some software, especially with so much open source software available. So here's an image or picture or whatever of Raspberry Pi OS. And you get that from Raspberry Pi. Actually, if you just Google Raspberry Pi download, you'll come across this image on their website, and you'll be able to download the version of Raspberry Pi that you need. In my case, I downloaded the Windows ISO file so that I could put it on my Windows computer to burn it onto the micro SD card. The micro SD card, again, is what is the hard drive for your Raspberry Pi. Raspberry Pi org provides this burner software, which you also install on your Windows or Mac or Ubuntu computer to burn the image onto the micro SD card. So after I purchased all the hardware and downloaded the OS and built my Pi Zero, before I hooked up the AC voltage to it and the sprinkler valves, I wanted to be able to test things without blowing up my Pi. So I wrote a little script, which was a lot easier than writing a script for the sprinkler timers. And I used a breadboard to hook everything together. And here's the LEDs and then the wires that I mentioned earlier, and they go to the GPIO pins on the Raspberry Pi. Now, this is not a Raspberry Pi Zero. This is a Raspberry Pi A, I think was the original one, the original model. At any rate, I wrote a little script and I'm going to play it for you to show that I can actually access the pins. So I hope this doesn't make anybody sick by me hand-holding the video here. So what I did is I wrote a little, like I said, a script. I think I wrote it in Python to turn on each of the pins. You can see I turned them on, turned them off, changed the timing a little bit, turned them on again, turned them off again, and then I just randomly turned the lights on and off. This kind of gives you a little bit of a visual of accessing the GPIO pins. And the breadboard, the purpose of the breadboard is so that you can put something together like this without having to do any soldering. If you change your mind or a component is bad or you broke it or whatever, all you have to do is plug in another one. You can see all the holes in the breadboard where you just plug all the different parts together. So now I needed, I decided against writing my own script to control my sprinklers because of all the different options that a pre-canned, pre-built piece of software can give me that would be way too much, in my opinion, to write. So I downloaded, after all the different reading I did online and all the different options of the software, I downloaded these two. I downloaded Open Sprinkler and HydroSys 4. And I had purchased 2 micro SD cards. So I put the operating system, Raspberry Pi OS, and HydroSys 4 on one of the SD cards, and the operating system and Open Sprinkler on another SD card. And that way I can use them separately on my Raspberry Pi Zero. So here's a picture of my setup. In the upper left corner here, you see the Raspberry Pi Zero. And Orva mentioned, I think it's like 3 inches by a 1/2 inch, and that's kind of what it is, about the size of your thumb. Below that is my switch to turn off the power to the relays here. And you can see the wires down at the bottom here heading off to my sprinkler valves. And then here's my power coming in, going through a connector. And I put a fuse on one of the legs, and then up to the voltage converter that goes from 24 volts AC, which is what comes in, to 5 volts DC, which powers my Raspberry Pi. Now the relays are powered with 24 volts AC, so I don't have to convert any of that. So after all that, here's a picture of Open Sprinkler. I took a screenshot of my computer when I'm running, and this is in a web page. So I run the sprinklers, or I programmed everything or set all the settings through my Windows PC just by opening the web page that Open Sprinkler puts on my network. Just like any other web page, except this is internal on my home network. The Raspberry Pi Zero does not have an Ethernet cable. However, it does have Wi-Fi. So I connect to it. It connects to my network through Wi-Fi, and I can connect to it through a web page. So you can see I have six valves, and I've named each one of them because they're connected 1, 2, 3, 4, 5, 6, and then this one is extra and this one is extra. And I'll show you in a video here what I use this last one for. So here I'm going to show you a video of actually the running my valves, but I don't have the sprinkler valves connected. I just have the relays connected in this video. So if you have your volume up kind of loud, you can hear the valves picking and dropping. And here, let me just play the video for you. And at the end of the video, you'll notice that an LED, I've turned on the LED, which was on wire 8, just to show me that the script finished. So I'll be quiet for a minute so you can hear the relays picking and dropping. Here's the LED I was talking about. So that was it. So I really couldn't show you the sprinkler valves going on and off because I didn't want to turn them off for 3 or 4 seconds and run around the yard showing you the watering, but you'll just have to take my word for it that the sprinklers do work. Here's where I got the information and all the different YouTube videos I watched and images. And by the way, if you're curious as to where I bought all my parts, they were actually all available on Amazon as I went through and selected what I wanted to purchase to make the kit. So that's what I have here. How do I stop sharing?
Up at the top.
I lost it. There we go. I think I stopped sharing, right?
You did.
I did.
Okay. Oh, thanks, Judy.
You're welcome. And that was so clear, we have no questions.
Oh, awesome.
Oh, never mind. Never mind. I don't know a lot about voltages. How critical is it to feed 5 volts DC into Raspberry Pi. If it was 6 or 7 volts, would that be bad? Or is the 24 AC transformer to 5 volts DC a standard piece of hardware you can buy?
Sorry about that. Yeah, yes. The transformer, the 24 volt transformer is a standard part you can buy. That's a doorbell transformer, and that's what I used. The other device that I had in there was the converter from 24 volts AC to 5 volts DC. You have to have that for your Raspberry Pi. You could not run your Raspberry Pi with 24 volts AC. You would burn it up.
How long did you take putting everything together?
Oh, off and on, I probably spent a month, maybe a month and a half. Now that includes purchasing parts and waiting for them to show up, that kind of stuff. And then circuit design, how am I going to do this? Writing the script to turn on the LEDs. And then with that, making the decision that I was not going to write the script for the sprinklers themselves.
And since you had done this before, it was easier for you to do it. You wouldn't recommend this for something as a starter project?
I think a starter project would be purchasing a Pi and actually seeing if you can log on to it. You know, purchase the Pi, download the OS, purchase the micro SD card. Now the thing, I'm running it, as Orb said, I'm running it headless. It has no monitor and no keyboard or no mouse. So I log into it via SSH through my network. And if you're not comfortable with doing something like that, you can spend a fair amount of time just learning how to do that.
Cool.
Before you build the project. Now, if you're not comfortable with building the Pi, the sprinkler timer, I actually have pulled up on my browser. Would you like me to share a screen and show that?
Sure.
Let's see here. Where is it? Right here. So here I have open, let's see, I can't see it because of the, there we go. Right here. You can purchase one from Open Sprinkler, which is the software I downloaded. Here is their Open Sprinkler Pi already built. And I think I believe it's $165.
Mm-hmm.
I'm trying to find it here. Here's the pricing, $149 to $186. I think that depends. I'm going to scroll back up here. That depends on how many output pins it has, how much it costs. But it runs the same software. It's not something I wanted to do. I wanted to build it because I'm a tinkerer. So I wanted to make it work on my own. Here is my live version of my Open Sprinkler running on my device right now. I'm logged in, as you can see, to the web page of the device. And this is what I'm seeing live. You can see the time is ticking. And it's currently telling me that the next time I water, which is tomorrow morning, is going to water 97% of whatever I picked for my backyard flowers, my front yard flowers, and so forth, for each of my sprinkler zones. And the way it picks that is by the weather in my location. And that's all configured as this Open Sprinkler software, which is the same thing that you would get if you purchased one.
Cool, thank you. And Dave lives on one side of the valley and I live on the other side of the valley, and we have different weather,
We sure do.
but the same lousy internet sometimes.
Well, I made it through. It didn't die, did it?
That is good. Over to you, John.
Well, actually, it's just me to pass the ball. Okay, great. Some more information. And again, as I said, we'll probably have more questions and discussion after we're all done. And at this time, somebody who is back in his home after having a little special vacation when Ida came around, Cal's back home. And so we're going to turn things over to Cal and share with us some more information about the Pi.
Well, we don't need any sprinklers lately. So.
And we're dying for water here.
Yes. Okay. All right. Is the slide showing?
I see it.
Okay. So I want to talk about running what I would call regular Linux on a Raspberry Pi 4B. And so I have a lot of experience with Linux, but mostly on the software versus the hardware end of it. And I've installed many x86 Linux distributions, kind of recovering old Windows machines for people in the club. And I had a Pi 4B back last year during the pandemic. I had nothing to work on. We weren't meeting. So I said, oh, look, here's the Pi 4B. Let me see what it's all about. I had previously had a 3, but I tried it. It didn't work as well. So the Pi is based on Raspberry Pi OS, as Arv was saying, which is a derivative of Debian. And I wanted to know, how does the Pi perform as with mainstream Linux desktop distributions? So can I use it like I use a regular computer that I run Linux on? That was kind of the quest. So here's the kit. This is a can of kit that Arv mentioned, the plastic case. And you can see the fan here at the top, and it is necessary, believe me, running a heavy distribution. It's the size of a credit card. It has a quad-core CPU. And this version, I have 8 gigabits of RAM. So, all right, 8 gigabytes is enough to run in any Linux today. What the kit gives you are a bunch of heat sinks, the micro SD connection, HDMI connections. This is where you put your video, and an off-on switch, and the power supply. We just talked about the power supply. It is a 5-volt, 3.5 amp. And you have to already have the keyboard, mouse, monitor, and the storage media, which is the micro SD card. So here it is with the top off, and you've seen enough of them now. The main chip is here, and that's the 8 gigabytes of RAM. Then here is where you normally would put your SD card to run it. This is all that's necessary for your hard drive, quote unquote. And it has the GPIO header and the Bluetooth connectors. And on this side, it has all the USB connections and the Ethernet. And down here, it has the audio. And you can have 2 4K monitors if you want. And the power comes in a USB-C. So that's what it looks like, size of a credit card. And I thought I'd talk about a little bit, I like to talk about the history of technology. The Raspberry Pi's story starts in 1979 when BBC, the British Broadcasting Corporation, had a project that wanted to teach computing in their educational system. They chose the Acorn Computers Company, and it made an 8-bit computer that everybody in Britain knew that learned in the 1980s. And this was basically an Apple II or Commodore 64 type machine. But in 1985, Acorn used what's called a reduced instruction set computer. And they did that because they wanted to handle video. And they started messing around with it. And they got good enough that the design team spun off a company called ARM, a division called ARM, Advanced RISC Machines. And their job was not to make the CPUs, but to design and sell the licenses. And they developed the ARM architecture. Architecture is kind of the set of commands for CPUs. So the x86 is Intel's architecture, and ARM is a different architecture. But it came out right at the time in 1990. This is when cell phones and all kind of mobile things were starting, the candy phones, and people just decided it was a good system, and they started licensing the technology, and it became kind of the industry standard. In 2012, some people formed the Raspberry Pi Foundation, and as Orv is showing you, they started that series of Pis for it, and they wanted to teach children in their schools the hardware, because everybody had just been teaching the software. And they made a business side, the trading limited group, and they have about 35 people now, and they actually design and sell the Pis. So they're kind of the who you get a Pi from, whereas the foundation is kind of on top of that, and they coordinate with them. Important thing to know is the Raspberry Pi is a system on a chip. One of the things is the CPU. There's the ARM CPU, but on the same single chip are the graphics processing unit, the display controller, the network coordination, the asynchronous and the synchronous buses, the audio, the USB. So it's a whole computer, bunch of chips that have all been driven into one. And they were used for these small devices. And what people did was they custom made each chip, but eventually we have a more common chip, and to make programs run on this CPU, you have to compile it to the ARM architecture. So if you have an open source program, you have it and have a compiler, you can compile it onto ARM or x86. One problem is that these chips were all made special and varied widely for a very long time, and for cameras and so forth. But there is no BIOS, there's no startup chip. You have to have the drivers for each one of these components before you start. There's no boot partition separate. You have to know it before you start. So how do you do this? So you bought a Pi, and I bought a kit, and now I have to get an operating system for it. And the default drive is a little micro SD card. However, since 2020, it's with a firmware update, you can boot off of one of the USB connections. And with also, if you have an adapter, a USB, you can use an SSD. So instead of running it off of a micro SD, you can run it off a USB or an SSD. And I'm going to show you the SD USB options. And as Arp said, the micro SD, the bad point about them is they don't last as long. They don't have as many write cycles. So number one is choose a fast micro SD card, as fast as you can get it, generally 60 megabytes a second, or a good USB 3.1 thumb drive or an SSD. And as Arb mentioned, try to find out which one has good quality, because there are bad USB drives, slow ones. So here I have, this is a micro SD card, and I got one of these little thumbnail type USB drives. And that's what I used on the Pi. So first off, you have to download the Linux operating system onto the drive. And you have to note that there are two architectures. One is called the ARM HF squashed format, or ARCH 64. And I'm going to tell you, I normally use the ARCH. The original architecture was ARM HF. And the process of writing this onto the drive is called flashing. You don't copy and paste, you flash it. Sort of the same thing, but it puts an image. I suggest, after trying a few things, you use the Rpi Imager. This is available. You go to the Raspberry Pi website, you download it, and it's available for Windows, Mac, or Linux. I used the Debian-based Linux version and just installed the program. So whatever system you're on, you install this Rpi Imager program. And this is the Rpi program running. So that's installed. And I want to choose my OS. It has a bunch of choices for you. And you will select and put it in here. You can choose the original Raspberry Pi OS, 32-bit. And I like that to make sure your Pi works if you want to operate external devices. Lots of hobby programs will give you examples using Raspberry Pi OS. So you can have a direct translation. You can customize it, and you can put in a previously downloaded Linux raw image. Of course, it has to be the image with the right architecture. Now, I've had success. You're going to have to go out and find it. I'd have success with Fedora 34, Ubuntu Mate, and there's also SUSE and Gentoo have been reported to work well. So you can download that appropriate architecture image yourself, and then let this program link it and put it in. Or if you're lazy, you can, as you'll see on the next page, there's some pre-baked into this program. And I'll show you the list on the next page. So the Rpi Imager, when it drops down and gives you a selection, you can choose the Raspberry Pi, or you can choose other general purpose, and that's Ubuntu. And most of them are server versions, but there is one desktop version. Or you can choose an Arch version, and this is Manjaro or ARM is based on Arch. And in Arch, you could have XFCE, Mate, KDE, GNOME. I guess you could have more, but these are the ones that are kind of baked in the cake. I've done this one, and I've done 2104, and I've done Manjaro XFCE. I tried a few others, but I found XFCE was the easiest. I'm not a real Arch person, and I'm not real good at the AUR and the Arch way, but I could get through with XFCE. So after you have chosen which one you want, then you take the media storage that you have, either the micro SD or the USB or your SSD, and you plug it into your main computer that you're going to flash it with, and you point to it, and then you write, which is flashing the operating system or onto your storage media. Then you take your storage media out and you stick it into the Pi and start the Pi up and follow your nose and just go along with whatever it asks you to do. Some of them have you should be hooked to the internet some kind of way for about 90% of these, so that they can go download additional software. When you look at the media that you have after you finish, after you've done all of this, and you take it out and you can look at it with some other device, you'll find that Raspberry Pi Imager has put a system boot, and that system boot has the exact drivers that you need. That's why you need to make sure you get a good, whatever imager knows that it's going in a Raspberry Pi. Then it will then install your normal ISO image for the OS. And I found that it doesn't take much. Like most media I would use have 64 gig or 128 gig, and you only need about 10 for the operating system at the most. I have later on gone back and repartitioned this if you want to make different partitions for various reasons. And there is something called Berry Boot, which is another kind of way where you can flash several OSs onto the same storage media. So now I did all of that. I started up, log in, and here's the system. Here you can see I originally loaded 20.10, Ubuntu 20.10, and upgraded it later on to 2104. And it takes a long time to upgrade because it's the old-fashioned way where they save one and load it up. So you can see that that's all it is, and a couple of wires hooking it together. The power and the video connection, and the wireless keyboard and mouse, and connected to the printer. As of yet, Ubuntu has not made an LTS available. I did a few other things, and here I have Fedora 34 running. I got the ARM version directly from Fedora, and Fedora has a media writer, their own version of the Raspberry Pi image program. And I tried it, but I couldn't get it to work. So I pointed to it. I used the Raspberry Pi Imager to load Fedora. Here's some general thoughts, my experiences as I've gone through this, is that there are quite a few Linux distributions now that make the correct architecture to run on ARM chips. And I've tested these kind of more extensively. And as time goes on, more distros are adding, taking the time to recompile their software. The Pi 4B or 400 with greater than or 4 gigabytes of RAM is recommended. And I recommend a fast system drive. And I found that the SD cards were barely doing it. The 3.1 USB performed admirably. And I'm sure the SSD would be even better. I want you to note that not all Linux software is available. Even though it's Linux, it has to be compiled for the ARM. And this you'll find especially a problem with Snap and Flatpaks at the current time. There are a lot of workarounds and you can do a lot of stuff. There's x86 emulators. I think Box 86 is the most popular. So if you're into it, you can force it, but be aware that a significant amount of Linux programs really don't yet work on ARM. So my general result is it's almost a workable desktop. It's fast enough for normal use, runs all the spreadsheets and a word processors, the video playback is very smooth. As Arv mentioned, if you're actually moving graphic objects around, that's not I/O, that's internal, and that you can see it kind of lag a little bit. And some of the peripherals have issues, printers and so forth, and the audio video options are somewhat limited unless you put more hardware hooked to it. People have done it, but I could not get Zoom to work, for instance. And the future, I think, is bright for Pi as more and more ARM chips are being used. You know, the Mac with their M1 chip is essentially an ARM type parallel technology. They're much more modern than the x86, but it will take a long time to move the incumbent out. So with that, I guess I can go to the question period.
Okay, we'll pass that back to Judy, as she is the one collecting. If you have questions, make sure you send them to Judy. So I think that was good to show people the steps to get started. And I agree with you. Just start out using it like you would a computer without programming it.
To be clear, you had to download the Linux OS yourself. The Raspberry Pi Imager didn't do it for you. You just told the Imager which one you were using. You think?
Well, if you use the Rpi Imager, it will download the necessary software. You don't have to go and get anything else if you went from the list that I showed. And then when you stick it in, if it needs more software, it will go download it. When I did Fedora and Mate, I had to go out separately and get it, and then let the Rpi Imager do it, point to it. So the answer is both.
Okay, this one is for Dave. Can you plug your system into a rain gauge?
Yes, there is an option with the Open Sprinkler software that allows you to use one of the GPIO pins to have input from a rain gauge. Yes.
Okay. This is for anybody. Can you explain headless more by making Pi a network device? Could you interact back and forth from your laptop, therefore not requiring a separate keyboard and monitor, making it integrated rather than a standalone device?
I guess I could answer that. The Answer is yes. There are two methods to do it. One is command line. SSH is the most popular version, secure shell. It's as if you were on a keyboard on the Raspberry Pi, but no GUI, command line. The alternative is use a GUI connection, could be via VNC or any one of those other graphical connections. If you're going to do that, I would recommend the Raspberry Pi be wired into your network as opposed to wireless. Because remember, everybody's fighting for the same wireless bandwidth. But yeah, both are possible.
But actually, to follow up with that,
Yep.
if you want to use VNC, it works quite well, and it's built into Raspberry Pi OS. So all you need is the other end on your Windows computer. Actually, you have that built in Windows as well.
Is there a Linux NUC, this is for Cal, available that will work similar to the RPI desktop?
NUC is the term Intel coined for a network something computer. It's a smaller a computer, a single board computer. Typically, NUCs are x86 based. They'll run Windows natively. Right. They tend to be a high-end SBC. You'll probably pay I don't know, $300 to $600 for them.
Yeah.
Once the system is loaded onto your micro SD, can you pop it out and copy it as a backup to another SD card?
Yes. And there are probably built-in backup programs for Raspberry Pi natively. You can run, in other words, you don't have to copy it to, well, you can copy it to, you can, as a backup, you can copy the image anywhere you want. It doesn't necessarily have to be another SD card.
Yeah, you have to copy it as an image.
Yes.
Is it practical to write and to compile software for a Raspberry Pi on a Raspberry Pi?
I think we asked this before. It is. All of the tools, all of the programming tools that are available for Linux, and there's a vast universe of them, are available for a Raspberry Pi because it's just Linux. The caveat is if you're compiling a very, very large program in a very, very complex compiling language, it might be kind of leisurely. So what you do is you do what they call cross compilation on a separate computer that might not be ARM. It doesn't have to be, but it'll compile ARM code. Then you copy it over to your Raspberry Pi to run it and test it.
My experience, when you get it fast enough, if you get an SSD or a very fast USB, you would not be able to tell the difference if you were running a standard laptop, desktop, or the Pi. They are very fast if you get a good enough drive speed.
Can someone compare the uses of Raspberry Pi with a ADURNO controller?
Anybody else have experience with Arduino? I have not used them myself. They tend to be a little more lower level platform, and most typically programs for Arduino are cross-compiled and then copied over to the Arduino. Anybody else have any experience?
Only peripheral experience through my son. He uses the Arduino for a lot of different things, and you're correct. He compiles everything on his Mac, and then using the Ethernet or USB puts it on the Arduino.
I don't think it's strictly headless. Is that correct?
It is. That is correct.
See, I knew I didn't know how to pronounce it correctly. Spelling works every time. Did you format the extra space on the OS flash drive as a separate partition drive, or did you extend the size of the OS flash drive partition to take up the rest of the space? That's probably for Cal.
Okay, whenever all of the images that I've ever used, they take 100% of the drive. So you have to go back if you want to do it and shrink the existing drive space so that you can add something else. So I use gparted to do that. So the answer is, when you make that first image, it hogs everything, which is why I showed that excess space. You have to recover it as a separate step.
Cal, I don't know of any situation where you'd really want to do that, would you? I mean, it wouldn't be, you'd have to mount it as a separate mount point, right?
Right.
Yeah.
Well, I just do it on all my machines. I have my, you have your home directory or your data directory in separate partitions, so that if I want to add other operating systems. Now this doesn't quite work the same way with Raspberry Pi, because it's got to make its own little boot. It doesn't have the BIOS type mentality.
Right. And you probably wouldn't want to make a separate home directory unless you're using it as a dedicated desktop. There wouldn't be any need if it was like a utility server or something.
Well, I use it for organizational purposes rather than technical reasons.
Yes, I understand that. And you guys are forgetting to put the initial for the question. Does the ARM architecture support running virtual machines? If it does, are standard Linux apps for KVM-QEMU support available? Presumably, it would be limited or only get decent performance for running ARM architecture virtual machines.
I don't know if I guess it'll run KVM, I don't know. But the main problem with a virtual machine is you are splitting your memory. So you're going to have, if you have 8 gigs, then you're going to have maybe 4 gigs for your virtual machine and 4 gigs for your main machine. And then you have speed, because it's got to translate through the virtual machine. So I think the answer is probably yes, but I don't think at the present time I would recommend it. Or
yeah, one of those yes, but why would you want to do it? Raspberry Pi is a pretty low-end machine. Splitting its available resources among 2 machines, one real, one virtual, is apt to be fairly leisurely.
So what I've done is I've got like 3 or 4 USBs. And if I want to put another operating system in, you just pull it out and stick it in. It really starts fast. I mean, it's like an iPad or something. It's so.
You would advise just booting a different drive if you want a different operating system.
Yes, I find that's much simpler and direct, and you just and you have enough space, so then you can stick another USB drive in if you want to store it. Again, the problem, if you have like an SSD, a big SSD, you don't want to wait. Once you've got it configured, you don't want to go in and reconfigure it. So it's a question of what kind of drive you're using in your strategy, I suppose.
Well, when you get to that point, maybe it's smarter just to have a common file server and store your data over there on from every.
Yeah, exactly.
Dave?
Yeah.
Could you use one of these for AnyDesk?
Actually, I did. I put AnyDesk on the Pi just to try it out. But yeah, you can.
Another one for you. I saw that the sprinkler system web interface was using a subnet. Are you using the same router for your home system and then using the subnet for your sprinkler system?
Actually, it's a port, not a subnet. It is actually on my home network. And it's a port number 80, I think it was 8086. I can't remember the actual number. Yeah, it's 8080. And it's the port that the Open Sprinkler is opening in order to get to its web interface.
I don't know who this is for, but is it easy to access your Raspberry Pi connected video camera via Wi-Fi remotely on a smartphone? Yes.
I have not connected a video camera or a camera to the Pi, but I would think it would be.
My answer was yes. Orv, Cal?
There is a dedicated Raspberry Pi application called Motion Eye. I have it running as a home video security system. That being said, a Raspberry Pi 4 with 4 cameras set at 720p, not HD, is using 90% of the CPU all the time. So if you were going to run a Linux-based home security system, I'd recommend something with a little more horsepower, especially if you had more cameras. So it's just a low-end Linux machine.
Or a camera port.
I'm sorry?
Do those cameras connect via a USB or through the camera port?
Mine are all IP-based cameras. Some are wireless, some are wired. But it can take USB also.
Is Python the most common RPI programming language?
The most common? I wouldn't say yes, but it certainly is a very, very popular programming language on any Linux system.
I think I just read that's like number 3 in popularity. And not to stray too far away, but there are hundreds of programming languages available for Linux and by default available for the Raspberry Pi. That being said, for quick and dirty 4 and 5 liners, Bash is a good way to go too. Bash is the scripting language that's built into the command line.
Yep.
Do I just connect my external SSD to a USB port? It doesn't hold the OS?
Cal, go ahead.
Yeah. Yes. I mean, if the OS, let's say the OS is on an SD card, the SSD is just another drive that you would plug in. I guess, if that's the question, maybe I missed the question.
I guess alternatively, you put the OS, on the boot partition on that SSD drive and tell Raspberry Pi, if you don't find an SD card, look for an SSD drive, and boot off of that.
Well, since December, I think maybe Arch, you have to tell it something, but once it's called the EEPROM, in the hardware now, if it doesn't find an SD card, it automatically goes to the USB 3 ports.
Yeah, that was a late update to the firmware, internal firmware. And I think you're right, Cal, it was last fall.
So what I did is on my RPI Raspbian, I updated Raspbian, I updated the firmware on Raspbian. And then once the firmware is done, then next time I'm good to go.
Yeah, and that's part of the stock release now.
Another for Cal. How many Linux containers? And then George says we run a dozen instances in our RPI class.
A container is like a very lightweight virtual machine.
Dave?
Yeah.
If you install a cutoff switch to shut down your system, will it shut down your timer? And if so, is there a way to install a cutoff switch to shut down your water lines without shutting down your timer?
Yeah, the cutoff switch I have actually just shuts off my relays. So if there's what I read on the internet is that this relay board, sometimes the relays stick open or closed, which would run my sprinkler valve 100% of the time. So that's why I put that in there. It just shuts off the voltage to the relay. So it doesn't make any difference whether it's open or closed. The rest of the question was, it doesn't shut off the Pi or the software. The Pi and the software are still running.
Thank you, and over to John.
All right, lots of good information. Right now, I'm going to call on another person to share their background with the Pi and what they do with it. So give me 2 seconds to click a button over here, and Craig Trout is going to,
Kurt.
Kurt Craig's the next one after Kurt. And
Find them together.
yep, Kurt, too many C's. Okay, Kurt, share with us, please, your knowledge.
That won't take long.
Now it'll take a little bit longer than me.
Quite seriously. The conventional way to play with a Pi is to take it out of the box and build get an operating system, stick it on a micro SD card. Now take the Pi, plug in the SD card, connect the keyboard and monitor, or keyboard and mouse, maybe wirelessly, connect the monitor, find a place to do all that. And that's fine. But what if we don't have all of that hardware or don't want to use it all? Can we still play with the Pi? The idea for this came from a good friend of mine who has much more of a command line interface history than I do. But the idea is to take and run a headless Pi. Can you take and run a Pi that does not have any head, i.e. it has no monitor, it has no keyboard, it has no mouse, okay? Can you take out of the box a Raspberry Pi and a power supply and an SD card and get that running, okay, without any other hardware connected to it? And the answer to that is yes. And it's called a headless Pi. And one of the ways to do this, okay, after you've taken and flashed your SD card, while it's still in your Windows machine, there are several configuration things that you can do on that card to make it join your network and be more friendly to you. So I'd like to take and share something that I do, if I can find it here. And I think I can. I'm going to show you a directory that I have on one of my hard drives. I can find it now. It's kind of small, and here it is. Okay. You're looking at a directory I've called it Raspberry Pi configs. It's got 3 files in it that have special meaning and use for the Raspberry Pi. The first of those is a file called SSH. It is a 0-byte file, which means its directory entry is a whole lot bigger than the file itself. When your Raspberry Pi is booting, if it sees this file, it will turn on SSH, which will allow you to use something like PuTTY to come in on a command line to it and do what you want, okay? There's another file here, it's a little bit advanced, and you can see it here called config.txt. There's a lot of things that could be put in config.txt, txt. The ones that I'm going to concentrate on right now are the ones that tell the Raspberry Pi, or tell Raspbian, actually, if you had a monitor, this is sort of the characteristics of the monitor that you would have. okay? And you can look these up in the documentation for config.txt and Raspberry Pi. But essentially what this tells me is that I have a widescreen monitor, okay, specifies the width and the height and the interface to it, okay. If you don't do this, you're going to have a problem connecting to the machine with VNC, okay. And one of the most important files that's out here for this headless configuration, okay, and I'm going to open it up in my favorite text editor. And now stop my share and start my share and find my supplicant file. Actually, this is not my supplicant file, and you'll know why immediately. Okay. This is a file that is going to tell the Raspberry Pi how to get connected on my network wirelessly, okay? The important part of here, and I'm going to highlight it so you can't read it, but then I'll turn it off, okay, is that the SSID of my network goes here and my network password goes here.
Kurt, all I see is a black screen.
All you see is a black screen. I am sorry. Let me try again. Are you seeing something now?
That looks better.
Okay. The really important parts of this, okay, are the line that's highlighted right now with the SSID. And that's where you plug in and make sure you get the, I think it is case sensitive, but that's the subsystem identifier of your wireless network that you wanted to connect to, okay? And also PSK is your network's password, okay? What this is going to do when your Raspberry Pi boots is it's going to tell it how to take and connect to your network. And your Raspberry Pi, the machine name, I believe, is Raspberry by default. The username is Pi. All defaults for this. But by putting these three files onto the root directory of that SD image that you just took and burned or flashed, whatever you want to call it, onto an SD card. You can do this under Windows now. You've instructed the Pi how to get connected onto your network. Okay. Now, once you have done this, okay, you can boot it. You can find its network address, its IP address on your network, and you can use PuTTY to go into it and run Raspbian config if you want, or do something like that. And we never have to take and connect anything. In order to do this, the only thing we have to connect to the Pi is a power supply. Now, if you're not running a Pi 4, my favorite power supply is an unused cell phone charger, preferably the 2-amp kind. They'll do very, very nicely, and everybody, you know, has a drawer full of them at home, so to speak. So that'll get you in business. And I am going to stop my share. We've had some discussion about Raspberry Pi cases, and I want to show you my favorite. Where'd it go? I lost it. Here we go. Here's my favorite non-Pi 4 case, okay? You can almost certainly buy these in your community. Okay. This is from Walmart, but Target carries them as well. It's a plastic soap dish, the kind that's got a lid on it. You just take and you modify this a little bit with the Dremel tool for holes appropriately, and you've got yourself a very nice Rpi case that doesn't look like much, but we're running a headless anyway, folks. So we can stuff it anywhere. If you want to run it regularly via Wi-Fi, all you need is a source of power for it somewhere in your house, okay? I run one on a regular basis, and I choose not to run it headless. So, well, I run it headless, but I run it on a network, on an Ethernet cable, and I run a thing called Pi-hole. Pi-hole is a hole for internet-based ads, okay? What it does is it blocks them, blocks a lot of them. It blocks the images for them. If the server of that image is on one of several lists of sites that they can serve ads, okay? So that's one of the uses that I've got for this, and one of the ways that I take and run this headless. I am going to try to find, yes, another page to share. Should be, well, we'll just do it the easy way. We'll do it on the screen. Okay. This is actually a browser. This is just Chrome. And I want to point out a couple of things here. It's not secure. Really don't care. It's on my home network. And you'll note that the domain name here is pi.hole. In configuring Pi-hole in your home network, essentially what you do is you use Pi-hole to take and be the source of resolving network addresses, internet network addresses, okay? Domain names and structures like that. On the Pi that I run my Pi-hole on, or I run Pi-hole on, in that configuration, I have what would normally be on a hosts file. I say that the domain name Pi, whose top level domain is hole, okay, is actually an IP address in my home network. So anywhere in my network, I can go and I can type pi.hole, and I can come into a browser interface that's running on my Pi computer, okay? And this is the dashboard for Pi-hole, the ad blocker. I've been running this for a long time. It blocks a lot of ads, so I just don't see them. Frequently, I'll see a blank space where an image might be, but it stops them. I also have this configured so that the root name servers that it goes to, I can't think who they're connected to right now. I think it may be Cloudflare offers this service, and some others do. They are domain name servers that will not take and resolve domain names that are known distributors of malware or known distributors of porn. There's several different levels that you can pick for that. But that's all configured within my Pi-hole. In my network router, that thing that I get from, in my case, it's CenturyLink, the configuration is modified in there so that when some machine connects on my network and looks to find where to get domain names resolved, it actually points internally to my Pi-hole and takes care of it that way. But with I've digressed a little bit with Pi-hole. I want to show something else. Okay, we talked about VNC, and we'll just share this. This is VNC, and it knows about 4 different Pis or 4 different configurations that have been connected to this VNC. One of them is the, let's look at, let's see if I can do this with a new share. And I can. Okay. This is the desktop for my Pi-hole. Okay, I could run other Pi-hole Raspberry Pi applications on here. I could use its browser. I don't know why I would want to. You can use whatever flavor of distribution you want to do this. There is not, other than the fact that it takes more space and might slow you down just a little bit, but not in actual use, there's no reason at all why you could not use the full-blown Raspbian with all of the applications on it. They don't cost you any performance if you're not using them, and they might be useful to have. I'm going to take and see about another. I'm going to split to a different. I think, yeah, we'll show the screen. That'll work. This is a Raspberry Pi 4. Okay, that is fully loaded up. It's got all of LibreOffice on it. If I want to play with it or do something with it, I can do it from here. This is another Pi in my network. This one is running completely headless. The only connection to this machine is power. If you are running Pi 4s, there's an admonition to use a 3 amp or larger power supply. If you put a Raspberry Pi 4 on a 2 amp supply, it will complain about low voltage, although I've actually measured the voltage and it's been coming into it, and it's been above 5 volts, and I can't explain that. But for Pi 4s, that's the only kind of Pi that I go out looking for a case for. And one of the things that I look for in the case is, does it come with a 3 or 3 amp power supply? And does the power supply have a switch on it in the cord for convenience? But with that said, we'll stop my share, and I'll take questions.
Yeah, if you have any questions, throw it through the chat box to Judy.
I got them.
Okay.
Is the Raspberry Pi version 3.14?
Is the Raspberry? I don't know.
Another thing,
I download whatever the current version of Raspbian OS is. I can't tell you what that is right now.
okay. Is VNC free?
Yes, there is a free Vnc Viewer. The one big drawback that the free one has is that you can't pump audio through it. Okay, but if you don't need to be able to get audio back to whatever machine you're controlling with it, that's not a problem.
How do you tell your CenturyLink modem how to point back to your RPI for DNS resolution?
You go in, this is a little bit esoteric for this, and it'll be different for each of your modems, okay, and providers. But if you go into the DNS configuration, In my case, CenturyLink will pre-program that with one of their domain name servers. What I do is I put my Raspberry Pi on a static IP address. That means it's outside of the dynamic range that I've got configured into my router. Okay. In my case, I use 225, and the dynamic range is something like .10 to .60. Okay, it's irrelevant. But the Raspberry Pi in this case has a static IP address. I use 225 because for some reason I can remember that. Okay, just like for a printer, I have that on a static IP address. Okay, and for some reason I can remember 172, or is it 176? It's one of them too. Okay. The important part there is that it's not going to change. And in my CenturyLink provided router, okay, I go into the DNS configuration on that and I override it. Now, one downside to that, or one thing to be aware of, is if that router gets reset, you need to go back and change that. But essentially, what happens after you do that is any device on your network that uses DHCP, Dynamic Host Configuration Protocol, to get its IP address, in the process of getting an IP address assigned to it, it will get the names, or more correctly, the IP addresses of the DNS servers that are going to be used. And the first one is my Raspberry Pi. The Raspberry Pi is configured that when it doesn't have a resolution, which is most of the case, okay, it will go, in my case, it's to the Cloudflare servers. I think OpenDNS also has a set of servers that are like this, that are, shall we say, PG rated, okay, and there's two levels of protection. One says, keep me away from all bad stuff, okay, which includes, questionable sites like porn, and then as a separate category, sites that are known to distribute malware. So if you have a machine on your system that is trying to get to, via the domain name, to a site known to distribute malware, it just will not resolve that address. You'll get either a not found, or you'll get a white screen. Some of the ads that I see on a daily basis in email, when I go through to read them, I see these great big white holes. And what was designed to be in that, by who created it? Well, an ad, and I don't get to see it. Occasionally, I will see a website that will complain that says something like, we distribute ads to make our income, and you're blocking them, so consider making a different choice. So, I usually do not open them up. You can also easily take the Pi hole, if you need to do it for some particular purpose. You can go into the interface on it and you can disable it either for a short period of time, and there's something like 15 seconds or a minute or 5 minutes, or indefinitely. So you can tell it not to do its filtering for a short period of time, and then you can either manually or it will automatically turn the protection back on. One other thing I should point out, for a reason that I don't understand, every once in a while the Pi hole would get hung up. So I've got an entry in cron, or a cron tab entry, that says every morning at, I think, 4:11. Okay, why 4:11? Well, 4 o'clock because I'm a night owl, but I'm usually not up that late. And 11 because it's a nice number that's not 0. And what I do is I tell the Pi to reboot itself every morning at 4, I think it's 4:11. So it does that. So every morning when we get up and connect our machines to it, it's got a fresh copy.
Two last questions, short and sweet and to the point. Does the Pi hole interfere with VPN operation? And so CenturyLink allows you to access their router.
Does it interfere with VPN? I wouldn't expect so.
And CenturyLink allows you to access their router?
The configuration on my side of the wall, absolutely.
Okay.
The ID and the password for that is usually on a sticker that's on the modem.
Got it.
I don't change those.
Okay. Over to John.
Okay, that was some more information. Kind of want to finish up. I have one other guest that I invited to share with us with some of the things that he does with his Pi, and that's Craig Wright, who's from the Columbus Computer Society. And Craig's done a number of different things with his Pis, one of which is creates a mirror, and he can do a whole program on that for you. So Craig, do you want to give us a couple of things that you do with your Pi and stuff? Oh, I got to switch it right here. He was right there a second ago, and then he moved on me.
Darn.
There you go.
Okay. I actually have about a dozen Raspberry Pis because I'm an idiot, I guess. But I've got a web server running on a couple of them. I have a proxy server sitting in front of that. So one of my Raspberry Pis is down for maintenance. The other one still does its job. And I actually use, speaking of cases, I have a little case like this, and you can bolt 2 or 3 of these together in a stack. And so the 2 Raspberry Pis that run my web server and the proxy server are all stacked together. So that looks kind of cool. And these cases, I just buy them locally at local store, and they'll fit just about any Raspberry Pi, including a Zero, though they're kind of overkill for a Raspberry Pi Zero. Let me share my screen briefly. Gotta click the right button here. So you can see here, this is a picture a couple of years ago, about a year ago, of my magic mirror. And there's a piece of two-way mirror glass. And you can see the lighter color, that the corners here and the corners down here. Up is there's actually a monitor behind it. And there's a Raspberry Pi 3, I think, running some special software to allow things like your calendar, news briefs, weather information. There's lots of different things you can put in there, and that will display in the background. Now, if you turn the monitor, or if you turn off the monitor, it just looks like a mirror. And that picture of Venice is actually a picture across on the other side of the room from where the mirror was when that picture was taken. So that gives you a little brief of what the mirror looks like. It's just a wooden frame, and there's the black part that isn't the monitor is just a piece of thin plywood that I painted black that backs up behind the glass. And then the monitor is just pressed up against the glass, and there's some little wooden brackets on the back to hold it against the glass so it doesn't fall out. This is kind of heavy. So when this picture was taken, it wasn't hanging on the wall. So it was just sitting on top of something. If you want to do a magic mirror, you go to a website called magicmirror.builders, and all of the software that you need to download and install You just download that and install it. And there's under documentation here, there's details on how to have it automatically start when you boot your Raspberry Pi. In fact, I just rebooted it a few minutes ago to make sure everything was up and running. Let's see if I can get to that machine. Just a second, I'll share this. Come on. There we go. Stop share, share again, share up. So I have a terminal window now. And this is actually the Raspberry Pi that's running the mirror software, just the text mode. And I have a little program that displays information about the network and that sort of thing when I'm using it. But there's a directory in my home directory called Magic Mirror, and in there is also a directory called config, and there's a text file in there, config.js. And it's just a little file that you put information about the various things that you want to do, like the clock. Put it in the upper left corner, 12-hour format, and show the seconds and stuff like that. The calendar, you can have different calendar files. I use a Mac, so all that information is then, I copy it over onto the Magic Mirror, and it outputs all of that. So this file's just use any editor. So I have a little compliments module that will display one of these little things, and it changes every couple of minutes. Don't eat yellow snow. Your cat loves you. Watch every episode of The Big Bang Theory, stuff like that. First of all, that show was funny. And since I'm a Buckeye, it also has Go Bucks in there. You can have news feeds, and I have several news feeds that I grab from it. It just randomly picks ones, including the local paper, CNN, the New York Times, BBC, whatever. So those show up in the bottom of the mirror, of the monitor part of the mirror, about every 2.5 seconds. Well, yeah. No, it's every 5 minutes it changes. Reload interval 5 minutes. So it's easy to configure that sort of thing. Physically, in creating the mirror, just get out your woodworking tools and some wood. I just use some cheap pine and some plywood because to make this little prototype. Eventually I use some decent wood to make something a little prettier. One of the cool things that, let me get out of this. One of the cool things I've done to make setting up a Raspberry Pi a little easier for some people is I wrote a document called the Unofficial Raspberry Pi Setup Guide. And this is it's a PDF document, and I have a website that you can grab this. So it's got lots of stuff in here about initial setup to how to create the, use the Raspberry Pi Imager to install your Raspberry Pi OS image onto a micro SD card, how to change the kernel command line. If you do that, that's that config.txt file that was mentioned earlier. How to turn on Wi-Fi, how to set up SSH. And then after you do the first boot, I actually have a couple of scripts that you can download, and it will ask you a bunch of questions, and it will set up some additional things with SSH, let you add new users, create a cron job to automatically update. I have some custom login scripts that gets updated about once a month. How to install various software. So we'll install Firefox or Emacs if you like that. It'll just say, do you want this? Do you not? Later, there's some specialized services, how to set it up for NAS, how to set up an Apache web server, an HA proxy server, if you want to use OwnCloud. This Tomcat one is very much in the early stage, so there isn't a lot there. How to set up SSL certificates. And I use a certificate authority called Let's Encrypt. One of the nice things about that certificate authority is the certificates are free. Most of them you have to pay some money for. The only pain is they expire every 90 days. So I have shell scripts written in a bash shell scripting language to update those scripts and move them to the right places automatically. And that runs daily. And I'm going to change it to run it weekly because you really don't need to run that every day. So if you go down a little bit, so if you want to set up a Samba server on your Raspberry Pi, it tells you install this software, how to set up a client on a Windows machine, how to set it up on a Mac, set it up on a Linux box, including a Raspberry Pi. Using NFS, that's a little harder to do. Can't really easily do that on Windows, but works great on Linux and on Mac. And what those let you do is easily share files across multiple machines. So you could even put your home directory on a NFS mounted disk so that all of your Raspberry Pis would use the same physical home folder, no matter which Raspberry Pi you logged into. That may or may not be something that you'd be interested in doing. Setting up certificates. So if you want to set up Apache, install that software, make some tweaks to a couple files, and go from there, setting up custom error pages, whatever. This document that I'm looking at right now is actually a PDF, and it's actually on my, I'm just visiting it from my, one of my web servers. So my web server is just my home little page, and this runs on a Raspberry Pi. And the one that's interesting for this is this Raspberry Pi. If you scroll down here where it says getting started with the Pi, click this, just click here to get a copy of that PDF. And it was last updated at 12/24 today.
Wow. Craig, could you
Yes.
Put the web address for that in the chat box so I can send it out with the follow-up material?
I will do that.
Outstanding, thank you. Now, have you heard of Cloudflare?
Yes.
Because that's the one that Kenneth uses. He says it's easier than Let's Encrypt. Just saying.
And I looked at that. The problem that I had is that Cloudflare keeps some of the files that might be interesting on their servers, not on yours. And I didn't like that, so I set up Let's Encrypt. I looked at Cloudflare, as a matter of fact. And maybe it was because I was a glutton for punishment. I don't know, but I went ahead and did it with Let's Encrypt instead.
Got it. Okay, thank you.
And I liked the fact that when I logged in here, that several of you had a picture similar to this as your background.
Per John Kennedy.
Yeah, and this is another, this was actually a very early picture. Well, I guess a year or so after the Raspberry Pi 4 came out, because originally it was 1, 2, and 4 gig, and now it's 2, 4, and 8. So lots of fun. And of course, I manage this whole thing using Word, and then I just export it to a PDF. And I have shell scripts that build the tar files that are uploaded to the web server and that sort of thing. So I do things where I don't have a lot of work. I just run a script and it does what it needs to do.
Thank you so much. We appreciate you doing this.
Short and sweet, and just a little bit of what, oh, and I have one other Raspberry Pi that's connected to a couple of relays, and it basically is, it's bolted to the inside wall of my garage, and it monitors and opens and closes my garage door via a web interface. So in addition to pressing the button in the car, if I leave and a neighbor call me and say, hey, your door's up, did you know that? I can just go to my phone and say, okay, go ahead and close it.
Very good.
So I guess that's it. Let me stop sharing.
Thank you. And I have a question for Kurt, and he is going to show us also how he, his CenturyLink information about what Dave's question was about. Richard asked, with no real-time clock, is the Pi able to have time set while it is powered on?
Yes.
I can.
I'll say yes, because that kind of, you guys are all going like this.
I can expand on that a little bit.
Okay, go.
It's true the RPI doesn't have any real-time clock, but you can buy a little tiny real-time clock module to plug onto the GPIO. That way, when it boots, it will have the correct date and time. In any case, when it boots, it has an NTP client set up, and it will go out and query whatever NTP national time protocol, I don't know. Anyway, it will go out and query an NTP server and set itself to the correct time at boot.
Thank you. And last but not least, Kurt, show us your stuff.
Unmute so we can hear you.
Okay, this is the configuration page within my CenturyLink router. I've signed into it and gone to advanced settings, WAN settings. And down here, select the IPv4 DNS type. Okay, that's the conventional 4-byte network ID. Okay, the DNS type is static, and this is common. The primary DNS is 192.168.104.225. That's where the 225 came from. The 192.168.104, 192.168 are very, very common for many routers out of the box, and they'll use either 0 or 1. And I wanted to have something that was of my own and known, and I pulled a 3-digit number between 0 and 254, I think, is the high limit here. 255 is possible. I pulled 104 out of that, and why did I pick that? Because that was my street number where I grew up as a kid, and it fits this. So my local network is all 192.168.104. The 225 in here is my Pi hole. Okay, the secondary DNS is one provided by, in my case, by CenturyLink. If I wanted to, I could go in and change that to any one of the other DNS servers. For all intents and purposes, we're never going to use that, so it doesn't make any difference what it is. We're only going to use that if the Pi hole is down and it's up all the time. So that's how you take and configure that.
Thank you. And please remember that Windows key print screen will give you a quick snap, and the picture will end up in your screenshots folder instead of having to take quick notes when something like that comes on. Over to you, John Kennedy, and take us off.
Yeah, that's been really great. I appreciate the 3 original panel members for taking part, and also for Kurt and Craig for sharing with us. I think this has given you a good background, a good start. I would just add that one other friend that's in our computer club that uses it, he uses his Pi to turn on his lights on and off, but he can connect to wherever he gets information for exact sundown at his latitude, longitude, so that every day it turns on and off at different times, other than the old-fashioned ones that we had that always turned on at a certain time. So it helps to eliminate that it's not always at the same time of the day. So there's a lot of things you can do. You know, just get started. You know, for 35 to 50 bucks, you can get one of these and just be amazed at what you can do with something that small.
And then learn one of the scripting languages to help you out, Bash or Perl or Python or whatever, to play around and do some fun stuff.
Absolutely.
Yep.
All right. Thanks so much for attending. We still have 2 more workshops this month. Judy will be sending out the registration links. We finally got the 3rd one scheduled, so watch for that. And then we'll be back in October, the 3rd Saturday or 3rd Wednesday for sure, with our next installment of Learning Linux. Thanks so much. Yep.
As usual.
Oh, okay, do that.
If you have not scheduled your Bob G security presentation for October, your October meeting, or we're spilling over into November now, please shoot me an email, jtalor@apcug.org. And thank you so much for attending, and thank you guys for giving your neat presentations today.
Thanks, Bill, for helping out with us. Also, we will always say at the end, if you have any suggestions for topics for future workshops, please send them to Judy. And if you have an idea of a workshop that you would like to lead or be a part of a panel, just like today, please let us know. We had no idea starting over a year ago that we'd be going this much, but it's been great. So those in the East Coast or West side of the Ohio Valley, it's time for your lunch. Us in the East, it's time for the afternoon snack. Judy.
And please remember, when I send out an email asking for volunteers for something, for goodness sakes, answer.
You mean like I didn't?
Yes.
Yeah, you and the bookend C's with the beards. Yeah. Mm-hmm.
All right.
I mean,
In my defense, I didn't know that I was going to be able to be here today.
Okay, we'll accept that. Cal didn't know with the weather. Dave didn't know because his internet's going crazy. So great. We appreciate you sharing. If you have any questions, I'll leave the chat box open for about 2 minutes. Otherwise, have a good rest of your day, and we will see you maybe next week or the following week. Thanks, Ord. Thanks, Cal. Thanks, Dave.
Thanks, John. Thanks, Judy.
See you guys.
thank you much,
Thank
Dave.
you.